Hi guys, welcome back to Career Diaries. Going to the next problem, the sliding window, sliding windows problem. So the problem we will be solving today is lead code 2932 maximum strong pair XOR 1. Okay, XOR XOR whatever. The problem statement is we are given a zero indexed integer array nums. Okay, a pair of integers x and y. Find a pair of integers x and y is called a strong pair if it satisfies the condition. Okay, the absolute difference between x and y is less than or equal to minimum of x and y. Okay, you need to select two integers from numbers. Okay, two integers from numbers such that they form a strong pair and their bitwise XOR is the maximum among all the strong pairs in the array. Shit, man. You need to select two integers from numbers so that they form a strong pair. Okay, they should be a strong pair, that is to follow this condition, and their bitwise XOR operation is the minimum among all strong pairs. Okay. So XOR, if both are, so if both are 0 and 1 1. Okay, if both are true and both are false, then we shall return. Okay, so guys, here, so since both are zeros, it will be 0, both are ones, it will be 0, and if it is 1 and 0 1 1 0 1, so the value is 3. We have to check, like we have to return the minimum of the strongest pair. I mean minimum XOR of the strongest pair. Strongest. Okay, we have to return the maximum XOR value out of all possible strong pairs in you can pick the same integer twice to form a pair. Okay, so 1 1 can be a pair, 1 2 can be a pair, 1 3 can be a pair, 1 4 1 5. But these are the strongest as they mentioned, because their absolute minimum, like their absolute difference should be less than or equal to minimum of x and y. So 1 minus 1 is less than 1, which is 0, and 2 minus 2 3 minus 3. So we can always consider same possibility pairs without checking, and 2 minus 1 is 1, so that satisfies the condition because 2 minus 1 is 1, which is less than or equal to minimum of x and y, which is 1. But we cannot take 1 and 3 because it will return 2, which is greater than minimum of 1 and 3 because 1 is the minimum. The maximum XOR possible from these pairs is 3 XOR 4. Okay, we have to return the XOR value. Fine. So how we'll be checking is we'll check the same valued ones and the next one until we don't find the maximum, and we'll be checking the if the strong is the strong test was passed, then we'll check the XOR as well and store it in a value. So let's create a two pointers. Actually, let's keep it P1 and P2. And P1 is less than length of actually don't need P2 here because we'll be creating P2 here. Uh, we'll be trying the DSF like the problem pattern we have done before, like the one we done before. That is longest even odd substring with threshold. We'll be trying the same approach with this. So while P2 length of lines and P2 minus P1 is less than or equal to minimum of, so I guess it's not like this. Guess this will work only if the numbers are in sorted order. So he didn't mention anywhere that the array will be sorted and the length of array will be between 1 and 50 and values will be between 1 and 100. So that you can pick the same place. Okay, it's not mentioned that the list is sorted, so we shall sort it first. We have to return the maximum XOR, right? So how do we XOR now? uh, what will be the XOR of same values? It will always be 0. How do we XOR it? Let's check Python binary operators. So this is the XOR operator. How this will work? Let's run check, and after completing the problem we will be discussing what was like, what is the intuition, what are we trying to do, and all the other stuff. Oh, seems like it's working fine. Yes, what we did here is, so we tried the same approach as longest even odd subarray with threshold. You can see the video in the you can see this video in the playlist, which will be right behind that, like this video. So we'll be like, we are sorting the numbers, and what we are doing is we're initially keeping the two pointers here, p1 and p2, and obviously p1 minus p2 will be less than or equal to this value. Yeah, will be less than minimum of p1 and p2, because it will be it will always be 0. So if you see, 1 1 2 2 3 3 4 4 and 5 5 are always valid. Actually, we don't even need to check this case, which will reduce time even further. Let's do one thing. Since we have, like, we already initiated answer with 0, the XOR operation on the same, like, the same values will always be 0. Let's check it. Consider we have taken 10. So taking 10 again will give us 1100 1100, which will, like, since it is following the same pattern, it will always encounter 0 with a 0 and 1 with a 1. So it will always be 0. So we are avoiding that one case. Let's check. See, so we'll be initiating uh, point p1 here and p2 here. Oh, but this might cause a problem. So we better keep it uh, like this only, because we are iterating through the p minus 1th position. I mean the last index. If we do p1 plus 1, the p2 will be out of bound. It might raise an exception, so we are not including it, and we are checking if p2 is out of bound or not. If it's not out of bound, we'll be checking the next condition, that is if the selected pair is a strong pair as defined here, that is the absolute difference is less than or equal to minimum of the both elements, and we'll be incrementing p2, and we are checking the XOR in the way as well. So we'll be taking the maximum of both, like maximum XOR on the way and returning it. Let's submit it and check if it is working fine for all the test cases. Yeah. So we are placed here, and so it is ranging from 17.4 to 18, I guess 17.9. Mm. The time complexity is order of n. Sorry, the time complexity is not order of n. The time complexity is order of n square. Almost, to be precise, it's order of uh, n into n plus 1 by 2, or we can say n square by 2. But I guess there is no other optimal solution than order of n square by 2. But there are solutions with 4 milliseconds, which might be probably linear, and just one for the range of 5 plus 1 and 9. It is doing the same thing. So that's it, guys. Uh, Everything seems fine. So I'm signing off. I hope you guys understand and keep working hard, and let's be a better self.